Okay, here's our video over. For the last few days we have been talking about congruent polygons, and congruent polygons, congruent shapes, have the exact same angles and the exact same sides as one another. So all the corresponding angles are congruent, all the corresponding sides are congruent. But today we're talking about similar shapes. This right here is the symbol for similar. And these two things are what happens when polygons are similar. The first thing is that your corresponding angles will be congruent. And that was just like when the shapes are congruent, the corresponding angles are congruent, so that's the same. But if shapes are similar, your corresponding sides will be proportional. Your corresponding sides won't be congruent, they're going to be proportional to one another. And I'll show you what I mean as we go through. Okay, and then if you ever see a statement like this, the order of the letters indicates your corresponding angles and sides. And we've already been practicing that a little bit the last few days. Okay, picture one. In the diagram, triangle ABC, and what does this little squiggle right here mean? Similar. So triangle ABC is similar to triangle DEF. So what it means to be similar, if you just look at these pictures, they may have the same shape, but not the same size. It's like my little mini whiteboard and the big whiteboard. They have the same shape, but they're not the same size. That's what it means to be similar. So if they have the same corresponding angles being congruent, that's what gives them the same shape. But the fact that the corresponding sides aren't congruent, that the corresponding sides are proportional, that's what makes them be different sizes. Okay, so I want to practice naming my corresponding angles, and then I'm going to mark it in the picture. So we've already practiced this. Angle A corresponds with angle D. Angle A corresponds with angle D. And that's because A and D are both the first letters in the statement. Okay, I know it says up here corresponding angles are congruent, so angle A is going to get a curve, and angle D is going to get a curve. Okay, second letter. Angle B corresponds with angle E, because they're both the second letters. So angle B corresponds with angle E. And once again, if shapes are similar, the corresponding angles are congruent. So angle B is congruent to angle E. So they both get two curves. Okay, and the last one, angle C corresponds with angle F. So angle C corresponds with angle F. That's because they're both the last letters in the statement. And once again, if shapes are similar, your corresponding angles are congruent. So angle C is congruent to angle F. So those will both get three curves. So if shapes are similar, the corresponding angles are congruent. Now let's do corresponding sides. So side AB will correspond with side DE. So side AB corresponds with side DE, but corresponding sides are not congruent, so I'm not going to put any tick marks on. Corresponding sides are proportional. So side AB compared to side DE will give me the similarity ratio that we'll talk about in a minute. That will be the same as side AC over side FD, etc. Okay, another pair of corresponding sides. Side BC, the last two letters, goes with side EF, the last two letters. So side BC corresponds with side EF. But once again, they're not congruent, they're proportional. Okay, and the last one, side AC, first and last letter, goes with side DF, first and last letter. So side AC corresponds with side DF. Okay, this next little section kind of practices what I said. So one more time. If shapes are similar, corresponding angles are congruent, but corresponding sides are proportional. So let's look. This tells me that ABCD is similar to EFGH. So if these are similar, that means they're the same shape, but not the same size. And I want to know something first about angle E. So angle E will be the same thing as angle A, because angle E is the first letter and so is A. So let's look. Do we know what angle A is? Angle A is 53, so angle E will have to be 53 degrees. And then I can actually put a 53 degrees in the picture. Okay, angle B is the second letter, so it's going to be the same as which one? Angle F. Let's look. Do we know what angle F is? Yep, it's 127. So angle B will be 127. So I'm going to put a 127 in the picture. Okay, so up here I knew that your corresponding angles are congruent. So I knew that whatever A was, that's what E would be. Whatever B is, that's what F will be. But now we're switching to sides. And sides aren't congruent, sides are proportional. So here we're trying to fill out the missing statement. So side AB is to side EF. Let's look at that. Side AB, first two letters, is to side EF, first two letters, as, the equals is read as, side AD, first and last letters, is to side EH, first and last letters. So we set up proportions. Okay, D. It says side GH is to side CD, as side FG is to side, take a second, what do you think? BC. And if you didn't get it, let's look. Side GH, last two letters, is to side CD, last two letters, as side FG, middle two letters, is to BC, middle two letters. Okay, now we're going to learn what a similarity ratio is. So a similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. So if I want to know the similarity ratio of triangle ABC to triangle DEF, so going from triangle ABC to triangle DEF, I just pick a side on this triangle. Let's say I pick the 3, and I compare it to the side over here that would correspond, which is 6. So 3 over 6, I get a similarity ratio of 1/2. But I could go the other way. If I wanted to know the similarity ratio of triangle DEF to triangle ABC, so this time going from DEF to ABC, this time I would put the 6 on top and compare it to the 3 on bottom, and I'd get a similarity ratio of 2. So the similarity ratio can either be from the left picture to the right or the right picture to the left. It kind of just depends on what it asks for. And if it doesn't specifically say, then I could put either 1/2 or 2. So what this means is this triangle is half the size of that one, or this triangle is twice the size of that one. That's what the similarity ratio means. Triangle ABC is half the size of DEF, or DEF is twice the size of ABC. Okay. Now we're going to decide if the triangles are similar. If they are, we're going to write a similarity statement, which means triangle blank is similar to triangle blank, and we have to give the similarity ratio, which is what we were talking about up here. Okay, so once again, shapes will be similar if the corresponding angles are congruent and if the corresponding sides are proportional. So first, let's see if the corresponding angles are congruent. It says to check to see if they're congruent. So A is congruent to D, B is congruent to E, C is congruent to F. So I do have 3 angles in this one, congruent to 3 angles in this one. So I know that all angles are congruent. So I'm good there. Now I have to check to see if the sides are proportional. So I'm going to start with the 15. And what would you compare the 15 to over in this triangle? The 20. Well, what ratio does that reduce to be? 15 over 20 reduces to be 3 over 4. Okay, let's see if I get that same similarity ratio when I check the other sides. Let's go to the 12 next. What would I compare the 12 to in this triangle over here? 16. So if I reduce that fraction, if I reduce that ratio, what would I get? 3/4. Okay, so far I'm looking good. And let's check the last set. So I'm going to go to the 18, and I'm going to compare it to the 24. And what do you get if you reduce that fraction? 3/4. Okay, because I got the same similarity ratio of 3/4 the whole way through, then that means that your corresponding sides are proportional. So I'm a go. Corresponding angles are congruent? Check. Corresponding sides are proportional. Check. That's because I got the same similarity ratio. So yes, these triangles are similar. So now I want to write my statement. Triangle blank is similar to triangle blank. Remember, you can name the first triangle whatever you want. I'm just going to call it triangle ABC. And what would you say triangle ABC is similar to? Triangle DEF. And then it wanted to know what's the similarity ratio, and the similarity ratio is 3 to 4. And you could have put that the similarity ratio was 4 to 3 if you wanted to. So this just means, the 3/4, that this triangle is 3/4 the size as this one. Or if I wrote it as 4/3, this triangle is 1 1/3 times bigger than this one. Okay, so once again, going through this, shapes are similar if corresponding angles are congruent, but sides are proportional. Not congruent, proportional. Okay, let's flip to the next page. And we're just going to try it again. I want to know if these two shapes are similar. So first I have to see if all the angles are congruent. So those two are congruent, those two are congruent, those two are congruent. Okay, so all corresponding angles are congruent, so I'm good there. Now I have to check the corresponding sides. So I'm going to start with the 12. And what would I compare the 12 to in the right picture? I would compare it to the 18. Did this one get you? Notice the 12 is between the one curve and the two curves. See, one curve, two curves. So I have to look for the side that's between one curve and two curves. Here's the one curve and two curves, so I have to compare it to the 18. Be careful, I tried to get you here. What do you get if you reduce that fraction? 2/3. Okay, let's see if we get that ratio the whole way through. So now I'm going to go to the 16. What would you compare the 16 to in the right picture? The 24. So 16 is between the 2 and 3 curves, and 24 is between the 2 and 3 curves. Okay, let's reduce that fraction. If you divide both of those by 8, you get 2/3. Okay, I've got one more to check. So I'm going to start with the 14. And the 14 would get compared with the 21. And if you divide both of those by 7, you get 2/3. So check. They have the same similarity ratio, which means all your corresponding sides are proportional. So you have 3 sets of corresponding angles being congruent, and you have 3 sets of corresponding sides being congruent, because they gave you the same similarity ratio. So yes, they're similar. Now I just need to make the statement. Triangle blank is similar to triangle blank. And I can call this first one whatever I want. Let's go XYZ. And what would you say XYZ is similar to? PNM. You have to make sure you match up your corresponding parts. And then the similarity ratio is 2/3. Which simply means that this triangle is 2/3 the size as that one. Now, if anybody had these flip-flopped and told me the similarity ratio was 3 to 2, that's okay. That just means that this triangle is 1.5 times the size of that one. Of course, it doesn't look like it because it's not drawn to scale, but that's what it would be. Okay, number 3. I want to know if these shapes are similar. So first I check the angles. I got 4 angles in this rectangle congruent to 4 angles in this one, so I'm good there. So my angles are congruent. Okay, now I have to see if my sides are proportional. So I'm going to start with the 20, and what would I compare the 20 with? The 30. What do you get if you reduce that fraction? 2/3. Okay, now let's compare the other two sides. So now I would compare the 36 with which one? The 52. I can divide both of those numbers by 4. If I divide both of those by 4, I get 9/13. I did not get the same similarity ratio this time, so no, these triangles are not similar. So for these quadrilaterals are not similar. For polygons to be similar, all the corresponding angles have to be congruent, which they were, and all the corresponding sides have to be proportional, which they weren't, because they didn't give me the same similarity ratio. Okay, in this next section, we're going to be finding angles and sides. So since I know sides are proportional, then I can set up proportions to find my unknown sides. Angles are easy because corresponding angles are congruent. Okay, so here we're told triangle FRI is similar to triangle DAY. Find the following. Okay, first it wants to know the measure of angle D. So angle D is the first letter, so it's going to be the same as angle F. So angle F is 70, which means angle D will be 70, because corresponding angles are congruent. Okay, measure of angle I is the last letter, so it's going to correspond with Y, and angle Y is 30, so that means angle I is 30. Okay, now I want to know angle A. Angle A will be the same thing as angle R. Oop, I didn't tell you angle R. So what are we going to do? What did the three angles add to be? 180. 70 and 30 makes 100. So angle R has to be 80 degrees, which means angle A has to be 80 degrees. And now I've got the angles. Okay, since sides are proportional, then I can set up proportions to find the sides. Let's start with X. So I'm going to start with X. And what can I compare the X to in this picture? I can compare the X with the 21. Okay, if I start with the right picture and go to the left, I have to go back to the right picture. So what else do you know over here? I can either use the 12 or the 10, but look to see what you have over here. Let's use the 10. And if I use the 10, I would compare the 10 with what over here? So 10 over 15. So X is to 21 as 10 is to 15. Right picture over left, right picture over left. Okay, so we solve proportions by cross multiplying and dividing. So this is when I multiply this diagonal. 15 times X is 15X. That will equal this diagonal multiplied. 21 times 10 is 210. And then you simply divide both sides by 15. And if you divide both sides by 15, that makes 14. So X has a length of 14. Okay, let's find Y. So I'm going to start with Y. And what can I compare Y to with the number over there? I can compare the Y with 12. Okay, this time I started with the left picture and I went to the right. So I have to go back to the left picture and then go to the right. So Y is to 12 as 15 is to 10. Okay, then I simply just cross multiply and divide. If I multiply this diagonal, 10 times Y, I get 10Y. Then I multiply this diagonal, 15 times 12. That makes 180. And then I would divide both sides by 10. And if I do that, I get Y is 18. So if you want to find sides in similar shapes, you have to set up proportions. Okay, these last two are basically the same. I imagine you probably get this with the proportions, and if not, we're going to practice some more tomorrow. So I think I'll stop there so the video is not too long. Smiley face!